11.3. Prove it. Let's prove our conjecture about slopes of perpendicular lines for the case where the lines pass through the origin. So the origin, if you remember, is the point 0, 0. Find the slope of a line passing through the point AB in the origin. So I'm going to write that again. Assume the line is not horizontal or vertical. Okay. So I guess the reason they're assuming the line is not horizontal or vertical, because then it would just be the x or the y-axis. So if that point AB was here, we would have I don't know why it's such a big deal, but whatever. Let's see what happens. So we got to find the slope. So I'm going to stack my coordinates. All right. If I'm starting at A and I'm going down to 0, that means I'm going to subtract A, because A minus A is 0. If I start at B and go to 0, I'm subtracting B, because B minus B is equal to 0, right? Anything minus itself always equals 0. Another word we have for terms like this, right, these are known as, like if I have A and negative A, we call those additive inverses, because when you add them, you get 0. So this slope, if I'm using change in y over change in x, that'll be b, negative b is my change in y, and negative a is my change in x, which I can also just say is b over a, because a negative divided by negative is a positive. 2. Suppose the line is rotated using the transformation rule x comma y, negative y comma x. Find the coordinates of the points a, b in the origin. Well, the origin's going to stay the same, right? No matter what I do to 0, 0, it stays 0, 0, unless I add or subtract from it, and I'm not doing that here. AB is going to be a little trickier. First thing we do is switch them. Then that first coordinate gets negated, so that would be negative b, comma a. How does the original line relate to the image? Well, I don't know a lot about this line, so I should probably find its slope. So let's stack our coordinates again. Negative b over a, 0, 0. Well, if I'm starting at negative b and I want to get to 0, I'm going to add b. If I'm starting at positive a and I want to get to 0, I'm going to subtract a. So that slope, change in y over change in x, equals negative a over b. And we can see that if I went from b over a to negative a over b, well, one thing I negated it, because this one's positive, this one's negative. And the other thing is I found a negative reciprocal. All right, so these lines are perpendicular. And the slope of this line is negative a over b. Compare your slopes. Just proved the slopes of perpendicular lines are negated. And I'm actually not a huge fan of calling this a proof. We used a point 0, 0. That's the origin. Really, you should always use variables, so they should pick a point, like call it maybe L, N. I think that would just be a lot more difficult to sort of conceptualize, so they used it. So I mean, this works, and it is the truth. So I'm not going to complain too much. But anytime you're proving something, it's really bad practice to use numbers. You should always be using variables or a placeholder.